Hi graded students, so I'm Sir Ariel, your science teacher. In this video, I'm going to discuss about the continental drift theory. Have you had a chance to go to a mountain, stand on its peak, and look at the beauty that it offers? Do you think it looks exactly as the same as before? Perhaps you would think that it might be different. All plain, no plateaus, no mountains. If it wasn't the same 10 years ago, how much different is it 10 million years ago? What about 100 million years ago? Can you imagine? In 1912, a German meteorologist named Alfred Wegener proposed a theory that about 200 million years ago, the continents were once one large landmass. He called this as Pangaea. Pangaea is a Greek word which means all earth. A Pangaea evolved into how the continents look today. This Pangaea started to break into two smaller supercontinents called the Laurasia and Gondwanaland 200 million years ago or during the Triassic period. Then, these smaller supercontinents broke apart, where the pieces moved slowly to their current locations. This is the theory of the continental drift. To summarize, continental drift theory states that the continents were once part of a large landmass called Pangaea, which drifted away from each other. The continents move away from each other towards their current positions. Let's say if you lived during Wegener's time, will you believe in him? Wegener searched for evidence to support his claim. So let's continue our discussion with some evidence supporting the continental drift theory presented by Alfred Wegener. One of the most visible and fascinating evidence that the continents were once connected is their shapes. Look at these continents. What can you say about their shapes? South America and Africa fit together. Then here, India, Antarctica, and Australia, this portion of the two continents, match one another. So that's the first evidence, known as the continental jigsaw puzzle. It means that the edge of one continent surprisingly matches the edge of another continent. Another evidence supporting the continental drift theory is known as the fossil correlation. So fossils are preserved remains or traces of organisms from the remote past, or these are the organisms that are extinct already, and most of them belong to a group of animals known as the reptile and also an ancient plant known as the fern. Okay, so these fossils of animals include the Cynonatus, it's a kind of land reptile. Then we have the Mesosaurus, it's a freshwater reptile, meaning it thrives in fresh water, not salt water. Then we have the Lystrosaurus, also a land reptile, and a fern plant known as the Glossopteris. So let's take a look one by one. So here, the fossils of this animal, the Cynonatus, was found in South America and Africa. So how can it be possible that these fossils can be found in different continents, knowing that this animal is a land reptile, meaning it can only travel through land? Okay, so Africa and South America are separated by a vast ocean, so it is very impossible for this reptile to travel from South America to Africa. So the similar fossils found in both continents simply shows that there's a possibility that these two continents were once connected. Another one also, it's a the fossil of Mesosaurus. can be found in both in this part of South America and Africa, and still this is a fresh water, so still it cannot survive in salt water like the ocean water. So still another proof or another evidence that can prove that the continents before were once connected. Then here we have the fossil of Lystrosaurus. It's a land reptile. So the fossils of this animal can be found in Africa, in some parts of India and Antarctica. So it's also a land animal, and these continents are still separated by an ocean. So again, it is still impossible for the land reptile to travel from one continent to another. So this simply shows that maybe before these continents were once connected. Another one is the Glossopteris fern. So we know that plants, one of the characteristics of plants is that they cannot move on their own. They stay in place. So how come that these fossils of plants, of Glossopteris plants, are found in different continents? South America, in Africa, in India, Antarctica, and Australia. So what does it imply? So it simply means that still the same concept that these continents were once connected. So that's the second evidence, known as the evidence from fossils, which means similar fossils of organisms from the remote past are found in the different continents. Another piece of evidence presented by Alfred Wegener is known as the rock and mountain correlation, which means that, by the way, when we say correlation, it simply means that they are identical or similar. Like for example, in this case, similar rocks and similar mountain structures had been found in the different continents, just like this one. So the mountains in this continent and this one have the same structures or composition. So what does it imply also, or what does it mean? So it simply shows that maybe millions of years ago, these two continents were once connected. So the rock formation in Africa lined up with South America as if it was a long mountain range, and the folded Cape Mountains of South America and Africa line up perfectly as if they were once a long mountain range. So same rocks and mountain structures had been found at the different continents. So that's the third evidence, rock and mountain correlation, which means identical rocks and mountain structures have been found on either side of the ocean or in the different continents. One more evidence presented by Alfred Wegener is the Paleoclimate Data, or the ancient climate. The distribution of glacial features in South America, Africa, India, and Australia is another proof that these continents were once connected. So by the way, what is glacial striations? So glacial striations are scratches formed on the rock surface due to the movement of glaciers. So glaciers are huge mass of ice and they are slowly moving on the rock surface. So since they're moving or touching the surface of the rocks, they create scratches, and these scratches are preserved, known as the glacial striations. So here, these continents being mentioned here have different climates. Like for example, Africa and India, some of the part of these continents have tropical climate. So when we say tropical climate, it is quite impossible for them to form glaciers or ice. So how come that there are some glacial striations? So it simply shows that there is a possibility that these four continents were once connected, and the climate that they have now may be different from their past climate. One evidence used by Wegener to justify his theory is the coal deposits. So coal deposits have been found in temperate and polar regions. So take note of that. There are coal deposits in temperate and polar regions. However, coal is only formed in tropical climates. So how come that there are coal deposits found in polar regions or in a temperate regions, and the only way for the coal to form should have a tropical climates? So it simply shows again, or to prove that the recent climate of the continent is different from its past climate. So the continents having cold climate now might be located in places wherein it has tropical climate. So another proof that the continents are moving. Alright, so let's summarize our discussion. So the pieces of evidence supporting continental drift theory are continental jigsaw puzzle, or the shapes of one continent fit to another continent. The matching fossils or correlation, similar fossils are found in different continents. Then rock and mountain correlations, so same rock age and same mountain structures are found in the different continents. And the paleoclimate data, or known as the ancient climate.